Hello students, this is Mr. Ezra. Today we are going to move on to a somewhat new topic and begin to talk about polynomial functions. So today we're just going to kind of introduce polynomials and begin to talk about some polynomial characteristics, not all. A polynomial function, let's see, a polynomial is a monomial, a sum of monomials with all exponents as whole numbers and coefficients that are all real numbers. For example, x to the third is a monomial. 6x squared is a monomial. 12x is a monomial. And 8 is a monomial. And the sum of all of these monomials is a polynomial. So a polynomial is the monomial itself. So like if I had x to the third, that's a monomial. That would be a polynomial just by itself. But if I also have a whole bunch of monomials that are added or subtracted together, then it could still be a polynomial function, okay? Now all of the exponents are whole numbers. We have an exponent of 3, 2, 1, and this is technically an exponent of 0. They're all whole numbers, and the coefficients are all real numbers. So the numbers in front of the variables, or the variables in each variable term, are all real numbers. They don't have to be integers or whole numbers, but they have to be real. They can't be imaginary. They can't be complex. They can't be something that's not real. Okay, so our first few questions today are, is it a polynomial? Yes or no? So we look at the first one. X cubed is a monomial. 3x is a monomial. We're adding those together. So yes, it is a polynomial. Monomial, monomial, monomial. But 5 to the x is not a monomial. You cannot have an exponent that is a variable. They have to be whole numbers. So part B is no, not a polynomial specifically because of the exponent that is a variable. What about C? Let's look at this one and see what we see. All right. We see that we have three terms, three parts. One of the parts has an exponent that is not a whole number. -1's not a whole number. Whole numbers don't have negatives. That's called an integer. So -1's not a whole number, and that means that this is not a polynomial because -2x to the -1 is not a monomial. So we get another no. So far we've got yes. All of our coefficients are real. All of our exponents are whole. We're good. The next two were no's because we had some things that were not monomials. What about this last one? -0.5x plus pi x squared minus √2. Okay, so we have an exponent of 1. That's a whole number. 2. That's a whole number. And this one doesn't have an exponent, so we're fine. We have a coefficient of -0.5, pi, and -√2. All three of these numbers are real, and since they're real, we get, yes, this is a polynomial. So things to look for that are big clues that it's not a polynomial are exponents that are either negative or variables. Also, we could not use exponents that are fractions. It has to be a whole number exponent. We like to put our polynomial functions in what's called standard form. Standard form is pretty simple. You're going to order from left to right in decreasing order of the exponents, which basically means that the largest exponent term is on the left, and we go in a decreasing order until we get to the smallest exponent term on the right. The smallest term can be the constant term, which does not have a variable attached to it. Okay, so we want to be comfortable with a term called degree. Degree is simply when you look at all of the parts of a polynomial, It is the one with the largest exponent. It's the largest exponent itself. That is the degree. And the degree tells you how many zeros the function is going to have. So when I look at our example here, the degree of negative 7x plus 9 minus 4x squared is 2. Why is it 2? Because the largest exponent is 2. It's that simple. And because the degree is 2, that means that there are 2 solutions. Okay, 2 is the largest exponent. That means that there are going to be 2 zeros or 2 roots. Okay, so some classifications. These are how we describe polynomials of different degree. These are words that you should know. If the degree is 0, it's called a constant. We'll see some examples of these in a minute. If the degree is 1, it's called linear, and you might remember linear functions from 9th, 8th, 7th grade. If it's got a degree of 2, it's called a quadratic, and we've been playing a lot with quadratics over the last few weeks. If it's got a degree of 3, if the largest exponent is 3, it's called a cubic. If it's got a degree of 4, it's called a quartic. And I'm going to add on a degree of 5 is called a quintic. Anything bigger than that, we're just going to say a polynomial of degree greater than 5. We're not really going to have special names for anything that's greater than that. Any polynomial that has a degree greater than 5. Okay. Leading coefficients are going to be important. The leading coefficient is the first coefficient, the number in front of the variable once it's in standard form. Okay, so if I have 2x squared minus 3x plus 5, which is in standard form, the leading coefficient is the number in front of the x squared, which is a 2. The constant is the term that does not have a variable attached to it. So any term, any part that doesn't have a variable is called a constant term. So here we have a leading coefficient of 2 and a constant of 5. So let's get some examples really quickly. To put this in standard form, which term must go first? Well, the terms are all of the parts, and the signs stay with whatever part. So negative 3x to the fourth would move to the front, then plus 12x to the third, and then plus 2x squared, and then minus 4 to put it in standard form. We want to put it in order from greatest exponent all the way down to lowest exponent. Now, once it's in standard form, the leading coefficient is the number at the front. It keeps the sign. So our leading coefficient would be negative 3. The constant term is at the end. It does not have a variable attached to it. It's just the number itself, and it keeps its sign. So this would be negative 4. And then the degree is the largest exponent. So here the degree is going to be 4 because 4 is the largest exponent. Because it has a degree of 4, we would call it a quartic function, Q-U-A-R-T-I-C. All right, our second example, what's going to go first in standard form, the 3 or the negative x? Well, remember, the constant term is always last, so we're going to move that negative x to the front and get negative x plus 3. The leading coefficient, now there's not a number in front of the x, but there is an understood number. Anytime you have negative x, it's like saying negative 1. So since there is an invisible negative 1 here, we would say that the leading coefficient is negative 1. If there's no number in front of the x, it would be understood to be a 1. The constant term at the end would be 3. So the constant term would be a 3, since that is the term without an x. And the degree, well, again, the biggest exponent is not listed, but what is it understood to be? It's understood to be a 1. Anytime you have an x by itself, it's understood to have an exponent of 1. So that degree would be first degree of 1, and we would call this a linear function since it has a degree of 1. Some polynomials have special names that are determined by either their degree or their number of terms. So we are actually going to have to add some vocabulary terms to our brains, and we're going to have to remember how to classify these polynomials. And these can be really easy questions for you to answer in the future if you can remember all of the names and why they are what they are. So if we look at the first polynomial here, how many terms does this have? Well, it has just one term, just 12. There's no addition or subtraction, it's just one term. And anytime there's only one term, we would call it a monomial. Monomials have exactly one term. The second example, 8x, also has one term, so we would also call it a monomial. Any polynomial that has only one term is called a monomial. Now, the degree is based off of the exponent, and 12 does not have an exponent. So what would be the understood degree if it's a constant term? It doesn't have an exponent, so we would say the degree is 0. If it has an x, there's an understood degree of 1. So if there's no x, it's like there's an x to the 0 power. X to the 0 is 1, 12 times 1 is 12, doesn't change anything. So the degree is 0. But if there is a variable without a number, it's understood to be 1. Anything with a degree of 0 is called a constant term. You might remember these functions being called constant functions, you may not, but anything without an x is called a constant term. So if you just have 12, or just have any number without a variable, it's called a constant. So this would be a monomial constant or a constant monomial. If the degree is 1, that's when we call it a linear function. So our example here would be a linear monomial or a monomial linear, either way. Okay. Now, when there are two terms, two parts separated by addition or subtraction, 1, 2, when there are two parts, it has a special name. It's called a binomial. So monomials have one term, binomials have two terms. That should make sense to you. Those prefixes, mono is 1 and bi is 2. The degree of our example here, 4x squared plus 3, the biggest exponent is 2, which would mean that the degree is 2. And if the degree is 2, then it's called a quadratic. We should be fairly used to quadratics after the last unit. If the biggest exponent is a 3, then it has a degree of 3, and we would call it a cubic. Okay. If there are 3 terms, like the next two examples, both have 3 terms. If there are 3 terms, we have a name for them. We call them trinomials, which again should make sense because mono is a prefix for 1, bi is a prefix that means 2, and tri is a prefix that means 3, like bicycle and tricycle. So 1, 2, 3 terms, 1, 2, 3 terms, trinomial. The degrees may be different. In this case, they are. We have a degree of 2. And if the degree is 2, we call it a quadratic. If the degree is 4, we call it a quartic. Degrees of 4 are called quartics. Now, we don't have an example of a degree of 5, but I will expect you to know that a 5th degree polynomial is called a quintic. These names you should be familiar with. I will give you a question on your next test for sure that asks you to classify the polynomial based on the number of terms and the degree. And if you can do that, you get that question right every time. Now, what if the number of terms is more than 3, right? If it's 4 or more, we just simply call it a polynomial. Or a polynomial of greater degree, or something like that. It's just a polynomial. They're all polynomials, but these, based on the number of terms, 1 term, 2 terms, and 3 terms have special names. Anything bigger than that doesn't have a special name. We just call it a polynomial. The same thing with degree. We have special names for degree of 0, 1, 2, 3, 4, and 5. And anything bigger than 5, or anything with a degree larger than 5, we're not going to give it a special name. We're just going to call it a polynomial of degree greater than 5 or something like that. And you probably won't see many of those. You'll probably be able to classify them pretty easily. Well, that is it for today. Hopefully this video was not too painful. There's a lot of vocabulary, not a lot of computation. Just make sure that you are good with that vocabulary and you'll be ready to go.